We'll proceed in pseudo multivariate calculus. Pseudo multivariate calculus. This is the discussion that we are pursuing. Okay, where we can write algorithm using any normal mathematics, and later on we will convert into calculus if it is required. That is the concern. And with that, we introduced a vector called length vector. So wherever length is required, and there we feel that it will be a vector and calculus, there we can replace it by length vector. Like work done. Work done is force into displacement. Work done is force vector dot displacement vector. If displacement vector is a straight line and force vector is a straight line, that is number one. Number two, force vector is pure numeric and displacement vector is pure numeric. In that sense, dot product of these two will give the work done. Nothing more is required. But what about force vector is a algebraic vector that is also called vector field, like xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. Okay, this is considered as the gravitational force of earth, r vector by r to the power 3 into constant gm1 m2. Anyway, minus gm1 m2. This is called force vector field, or xi plus yj, yi minus xj. These are vector field algebraic vector, algebraic force field. Okay, that is one scenario. Second scenario is displacement vector is not a straight line. Displacement vector is a curve. Okay, if I talk about if I talk about displacement vector of this, then first I should know the equation of the line. What is the equation of the line? Consider this is x-axis. Then equation of the line, consider it is y equal to 4x. That is the equation of the line. Then what is vector representation of y equal to 4x? What is vector representation of y equal to 4x? That is under question. What is vector representation of y equal to 4x? How we describe any vector out of a straight line? Vector is nothing but I plus dy by dxj. Okay, I believe it is all right, into x if someone is very particular about it. Like this is what we are talking about, length vector. That is I plus dy by dxj. I plus 4j. This is the vector representation of line y equal to 4x. I plus dy by dx 4j. Why it is dy by dx? Because vector representation is a vector that is passing through 2 points. A vector that is passing through origin and it is passing through any point x comma y. Then x comma y is nothing but dy by dx. I believe it is all right, provided x is 1. Dy by dx, when x is 1, how much is the y? That point is y comma 1 comma y. So in that case it will be I plus dy by dx j. Okay, I plus dy by dx j, what are you talking about? I am talking about a vector that is passing from origin 0 comma 0 and passing through a line that is 1 comma dy by x. Then it will become I plus y by xj, I plus dy by dxj. Okay, in that sense, line that is y equal to 4x will have vector representation as I plus 4j. This is a static vector. And now I want to calculate the work done by a force field. Force field is a numeric vector. Consider the numeric vector is j, just j. Means if this is x-axis and this is y-axis, then force is going along the j-axis. If this is x-axis, this is y-axis, then force is going along Jx, y-axis. Force field is J. In that case, what is the work done along a line that is y equal to 4x to move an item from origin to any point x comma y? What are you talking about moving an item? Okay, moving an item means like item is an item. It is really an item. And force field, I am saying it is like this. Consider force field is minus J. That is the earth gravitational pull. The force field is minus J. That is the earth gravitational pull. And then displacement is along a line that is y equal to 4x. Means there is an item. An item is traveling from here back to here, origin. This point is x comma y. This is happening because there is a force field exactly vertical that is going toward the earth, and that force field is xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. Okay, then work done is force field dot product with this vector. This vector is I plus 4j. Consider this force field. Now, this force field, what we are talking now, consider this is minus j constant, that is numeric vector. And displacement vector along which the item would move is also a numeric vector, that is I plus 4j. Then what is the work done to get an item moved from a point that is 1 comma 4 to 0 comma 0? How much earth is losing energy? Earth is working here. If item is standing here, stranded here, and it is moving like this, if there is a velocity in a mass, then someone is then energy is involved. Mass into velocity square is the energy, as per Sir Einstein's theorem. Energy equal to mass into velocity square. If item at this point, just calculate the velocity how much, or any moment calculate the velocity how much it is, and square it, multiply with the mass. That much energy at that moment Earth is liberating. Okay, so Earth is liberating energy when something is moving. How much it is? That is force vector dot product with the displacement vector. That is minus j dot with I plus 4j. That is minus 4. Minus is coming because minus 4. And then from where to where? Minus 4. Okay, then there is nothing called where to where. That is what it is, I believe so. Force vector into displacement vector. Displacement is 4 if I am taking I 4j, means 4 is the height. For the height 4, and since force is in y direction, 4 joule of energy got liberated. Okay, that is very straightforward. But okay, so we came to a formula. This is called force vector dot displacement vector. What about force vector is an algebraic vector xi plus yj minus yi minus xj yi minus xj. If that is true, if that is true, then it will be kind of in a circular fashion anti-clockwise. That is the force. In a circular fashion anti-clockwise, that is the force yi minus xj. Okay, if that is the scenario yi minus xj is the force, then what about if this displacement is also not a straight line like this? I have talked about it. This is x-axis, then this is a curve. If this is a curve, then displacement is happening from a point. This equation of this curve is y equal to x square. Y equal to x square. For x equal to 4, there is a point called 16 here in y. There is a point called 4 comma 16. From 4 comma 16, one item is going down like this. Okay, one item is going down like this. Now, if force field is algebraic vector, force field is algebraic. Consider the force field is xi plus yj, just xi plus yj, and displacement vector is displacement is this, that we don't know. how to describe the displacement? That is the question. Anyway, this is here the pseudo mathematics come into the picture. Force vector dot product with the displacement vector or length vector is the net energy calculation. This is the pseudo algorithm for calculating the work done. What is here? The force vector, consider force vector is xi plus yj. Now I am replacing it with xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. Now consider force vector is xi plus yj plus zk. Denominator I am removing for calculation simplicity. Now the earth gravitational pull xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. This is considered as path independent. We will talk about it in generic fashion, how we know that this is path independent. Trust me that xi plus yj plus zk, it is also path independent. Okay, both are path independent. Xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. This is path independent, and xi plus yj plus zk is also path independent. So earth gravitational pull we are taking as xi plus yj plus zk. This is earth gravitational pull. Okay, in that sense, it is making a traveling through a displacement. Displacement is like this. So net energy calculation is earth gravitational force, that is F vector dot product with the displacement vector. We will replace displacement vector or length vector with our length that we have introduced. What is length vector concept that we have brought in? Please watch our previous video. So length vector, how we have brought in. Length vector for any curve is I plus dy by dxj bracket close into dx. This is the length vector. Wherever I need a length or length vector, I just introduce this. What is your length vector? If I do dot product of this length vector with the force, it gives me energy. If I do cross product of this length vector with another length vector, it gives me area vector. If I do cross product of this length vector with another length vector and whole, that is come as area vector, dot product with another vector gives me volume or volume vector. It won't be vector, but whatever it is. Cross product of two area vector will give me weight vector. Means amazing, mind-blowing this length vector is. Now we will proceed now. Now I have a force field that is xi plus yj plus zk, and then I have a length vector that is, okay, here this is x-axis, this is y-axis, and this is z-axis. Mind it, this is x-axis, this is y-axis, and this in my side, this is z-axis. This is how it is. Now xi plus yj plus zk is the force field dot product with the length vector is the net work done. That is I plus dy by dxj into dx. I plus dy by dxj bracket close into dx, or dxi plus dy by dx into dxj is the length vector. Okay, if that is the scenario, then I have to do dot product of these two. So zk will go away. Now dot product when it comes, then it will be x dxi plus y into dy by dx into dx. Okay, this is how it is. So this will give the net work done calculation. Okay, so let's start. So idea for this discussion is that is this work done, the work done that we are calculating, if this work done by the path independence vector field is really path independent? That is a question. Is it really path independent? Because if we know that force field is path independent, then calculating the work done between any 2 points will be will be independent of the path we are taking. Okay, then only I can say that force field is path independent. Like earth gravitational pull is path independent. If a person is standing on the 10th story of a building, a person is standing at the 10th story of a building. Now from there, he is dropping a ball on a staircase. And ball is dub, 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 dub. Now it is coming to first ground floor. Now, as I always say, that if something is moving, then energy is involved. Who is working here? Earth is working here. In that sense, the how much Earth has lost the energy, how much Earth has done the work. Now that person went to the window on the surface of 10th floor and he drops the ball. Now ball comes and it hits the ground. Now at that moment, what is the energy lost by the earth? Or it is going by a staircase. Dub, 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 dub. Or he took a round staircase. There is something staircase called round staircase. In round staircase, the ball will go like a round fashion. Okay, then what is the work done? Earth gravitational pull is path independent. Path independent means the net energy lost by the earth is dependent upon the begin point and end point. That's it. Not on the path you are taking. Either it is a staircase or it is a round stair or he is dropping directly, doesn't matter. Okay, it matters in the sense if there is a media in between, that media is absorbing the energy. Like a staircase, there is many sand someone has put down. Then probably ball will stop in between only. Okay, there should not be any energy absorbing media out there. Then it is path independent. So Earth gravitational pull. If I know that the Earth gravitational pull, that is xi plus yj plus zk, is path independent, then idea is, since we have brought a concept of length vector, that is I plus dy by dxj bracket close into dx, this is called length vector. When we have brought the idea of length vector, then force vector dot length vector gives the work done. If that is true and force vector I know it is path independent, then length vector, if I take a length vector for a curve that is y equal to x square, or to a line that is y equal to 4x, that will be a line connecting origin and a point called 4 comma 16, that is y equal to 4x. Or there will be another curve that is y equal to x square, that will also connect 0 comma 0 to 4 comma 16. Or there will be a path that from 4 comma 16 it will drop directly to 4 comma 0, and from 4 comma 0 it will go to the origin. Okay, 4 comma 0 it will go to the origin, and from 4 comma 0, from origin to 4 comma 0, from 4 comma 0 it will go to 4 comma 16, this vertical path and horizontal path. Now prove it that it will take same energy. Then I know, then it will be more or less will move toward the validation of our approach, that is called length vector. Your length vector is error proof. What? Because it is, we are going towards pseudo multivariate calculus, where we are writing algorithm just like a normal mathematics, and then later we convert into calculus. That is pseudo multivariate calculus. Let's try with the straight line first. If it is a straight line, then equation of this line that is connecting 0 comma 0 to 4 comma 16 is y equal to 4x. What is the work done? Work done is force vector dot length vector. Force vector is xi plus yj plus zk dot product with I plus dy by dxj bracket close into dx. Now ij will remain, k vector k will go away. Now it becomes now x dx plus y into dy by dx. What is dy by dx? It is 4 now. Y equal to 4x, x is a line, then dy by dx is 4. In that case, it becomes 4 into y. Y is 4x because we are calculating along the line. So force vector will work along the line. So y equal to 4x and dy by dx is 4, 16x. Now we have here x and there 16x, 17x dx. That is the net energy calculation. X is from 0 to 4 or 4 to 0, whatever it is. Now 17x integration is 17x square by 2. If it is 17x square by 2, then x is 0 to 4. Then it is 17 into 0 to 4. 4 square by 2. That will come as 8. 4 square by 2 will come 8. 17 into 8, how much it will be? 17 into 8. 8, 7, 56, I believe so. 5, 8, 5 plus 5, 13, 136. So net energy is 136 that Earth is losing. Now take another path. Another path is a straight line. I'm sorry, another path is a curve that is y equal to x square. Now start again. Our xi plus yj plus zk dot product with length vector I plus dy by dxj into dx. Now it becomes xi, it becomes x plus y dy by dx bracket close into dx. Okay, now x is alright, dy by dx is 2x. When y equal to x square in a curve, dy by dx is 2x. Now 2x into y is x square, 2x to the power 3. Now integration is for x plus 2x to the power 3, x plus 2x to the power 3. Now it will become x square by 2 plus 2x to the power 4 by 4. Net integration will become, see the integration is different, right, for every path. Okay, every path. Earlier, I believe the integration was 17x square by 2. Now the integration with different path with our length vector approach, it is now x square by 2 plus x to the power 4 by 2. Now x is 0 to 4 or 4 to 0, whatever. If that is the case, then the first one will become 8. 4 square by 2 will become 8 plus x to the power 4 by 2, that is x to the power 3 into 2. 4 to the power 3 is 64. 64 into 2, 128. 128 plus 8, 136. Same reason. So, two path it is giving same reason. So, looks like it is a candidate for path independent. The force field is path independent, I know, but through our approach, we are in phase of proving it is path independent. Okay, let's try third approach, that is the most complex one. Third approach is that if we are calculating x-axis, if we are calculating the item is going from a point 4 comma 16 to 0, then we will take it first vertical path and then horizontal path. Vertical path if I take, then I plus dy by dx j into dx, this is a length vector we have calculated, it will not work. Because dy by dx for the vertical line will be infinite. It will not work at all. Let's go back how we calculated length vector. Length vector is an idea that comes when we try to calculate the length of a line. If there is a straight line called y equal to 4x, then what is the length of the line from a section 0, 0 to section x, y? This length is same as the vector representation of this line and magnitude of that vector, that is xi plus yj. In that case, magnitude of this vector is, I'm sorry, vector representation is xi plus yj. The magnitude of this vector is x square plus y square square root. That is the length of the line section from origin to this one. So now, since we want this length for the every line, this curve is also a line. This is a screwed line, but this is also a line. This curve is a line. Then what is the distance? What is the length of this line from a point, any point x comma y to origin? Okay, if I denote this x comma y in origin as a vector, then this will come as a vector. If this will come as a vector, then vector representation is xi plus yj. This is we don't want, because if I calculate the magnitude, it will give the magnitude of this vector rather than the length of this curve. Length of this curve will not come into the picture. Only length of this vector will come into the picture. In order to have length of this curve, we took out x from it, xi plus yj, and it becomes I plus y by xj bracket close into x. Here y by x is there because y by x for this curve is different at different moments. So y by x, that's the difference between a curve and a straight line. For a straight line, y by x at every moment it is same and it is a constant. Whereas for curve y by x is actually it will come as algebra. And if I calculate for a particular x, everywhere y by x will be different. So our vector representation should have y by x. So xi plus yj become x become x into bracket I plus y by x. And now y is dependent upon x and it is algebra. Y by x came as dy by dx. So I plus dy by dx j bracket close into x. Since this vector is dependent upon an x that is on right side and this is multiplication, it will transform into integration as per the primitive calculus. So it becomes I plus dy by dx j bracket close into dx. But it will not work here when we are trying to calculate the work done in a vertical line because dy by dx will be infinite. In that sense, we will go with the dx by dy. That will be 0. For vertical line dx by dy, per change in y, how much x is changing? That is dx by dy. These are our calculations. This is not available in any of the book. Please do not please mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. Anyway, now we have the original vector is xi plus yj. I'll take out y from it. Now it becomes xyyi plus j bracket close into y. If I place it into calculus, it will become dx by dy I plus j bracket close into dy. Now we will apply for the vertical path. If I apply for the vertical path, then force vector dot displacement vector is the energy. Plus, then we will apply for the horizontal path. We will add these two and then we will see that it is really doing some magic. Anyway, force vector is xi plus yj dot product with dx by dy I dx by dy I plus j bracket close into dy. Dx by dy is 0. If I move along y-axis, dx by dy, if I move 1 unit along y-axis, how much x is changing? If I move along this anywhere in the y-axis, x is not changing. So dx by dy is 0. If dx by dy is 0, it means that first I component will go. From there also it will go. It will become y dy. The net integration will be y dy. That will be the net integration. Y dy integration is y square by 2. Y dy integration is y square by 2. What is y square by 2? Okay, where y is 0 to the height, that is 0 to 16. So 16 square by 2. Okay, that is 16 into 8. That is 128. Anyway, now let's calculate the horizontal path. Horizontal path is from 4 comma 0 to 0 comma 0, and this is I plus dy by dx j into dx. So that will work. Now we'll proceed again. Force vector dot displacement vector is the net energy. In that sense, force vector is xi plus yj plus zk dot product with I plus dy by dxj bracket close dx. In that sense, it will come at x plus y into dy by dx. Okay, anyway, what is dy by dx here in on this? Then on x-axis 0 dy by dx. If I move 1 unit along x-axis, how much y is changing? Y is not changing. Or along x-axis, you move any unit along x-axis, y is always 0, constant. So dy by dx is 0. In that sense, it will come as x dx. Integration of x dx is x square by 2. Integration of x dx is x square by 2. If that is the concept, it is x square by 2. If that is the concept, then it will be integration limit will be 0 to 4. That will be 0 to 4. 16 by 2, 8. 8 plus 8 is the energy along the horizontal line, and 128 is the energy that is involved in the vertical line. 8 plus 128 is 136. At least we could find out that with three paths, the energy calculation is exactly same when we know that force field is path independent. So we are proceeding toward our approach, that is to multiply force with displacement, or to dot product of force with the displacement vector brings the net energy where force vector is path independent. Then we are seeing that we are moving toward path independence, and three paths we have tried, and it is coming as 136 is the energy. Person is free to calculate more path. There is no hindrance in it. Anyone can try more path. What can be more path? I believe someone can try sinusoidal. It starts from 0 and it goes till 1. Okay, so here it is pi by 2 and here it is 1. From 1, there will be a straight line that will go to point. If I take sinusoidal, then, I believe that it will go from 0 and it will come back to 0 again. Okay, then this is the path, one path. Another path from 0, from 0, 0, I'm sorry. If someone takes sinusoidal, then it starts from 0, comma 0. It goes and it meets x-axis again at a point called pi, comma 0. Now from pi comma 0, someone can take a straight line and it will go to 4 comma 16. Okay, now that line someone will try the energy calculation, and then someone will try energy calculation in the sin x. What is the energy calculation in the sin x? And then it will, what is the energy calculation in the sin x? Okay, that is xi plus yj plus zk dot product with I plus dy by dxj dx. Now it will come as x plus y dy by dx whole multiplied with dx. dy by dx of sin x is cos x and y is sin x because we are taking through that path. Sin x into cos x. Okay, now it becomes x plus sin x cos x. This I have to do integration with the dx. Okay, people are free to do so. X will become x square by 2 and sin x cos x integration I really don't know what it will come, sin x into cos x. Anyway, people are free to calculate it, and then limit will be x is 0 to pi. Whatever comes from pi comma 0, there will be a straight line, it will go to the 4 comma 16. Find the line equation, or someone can try pi to 4 comma 0, pi comma 0 to 4 comma 0, one energy, and then one energy 4 comma 0 to 4 comma 0 to 4 comma 16, or from pi comma 0 directly to 4 comma 16. We'll proceed on this. Okay, so with example, we have proved it. If force field is path independent, then with our approach, doing the dot product with the length vector, doing the dot product with the length vector, actually it comes as path independent. Even though the integration what comes as the algebraic equation in x, only in x, that is different for different kind of path. That is the clue. For different kind of path, the net energy algebra that is coming is different, but still applying the limit, it comes to same. So it is path independent. Now, someone would ask, there can be infinite number of paths between 0 and 4 comma 16. How many paths you will try and say that your length vector is all right? Okay, I don't trust you. So can you go with some generic proof where you will prove that your length vector to be applied, that is I plus dy by dxj into dx, apply it as a simple length anywhere and it will give you the result. Or just calculate this magnitude of this length vector, you get the length, absolute length of a curve. It is a magic vector. Can you prove with some kind of generic way that if force vector is path independent, then indeed it will be path independent. Okay, so that we will prove it. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.